Lakshana Bagmari, and today I am going to take 9th standard science. It is from Maharashtra State Board. Today our chapter is related to sound. Now about sound you have learnt in previous standards also. Today we will learn the chapter the music of sound. Now let us start. Now what is sound basically? You can discuss with your friends, with your teachers, and you can define the sound as you have learned. Actually, we hear a sound because vibrations are produced in a source of a sound. For example, now I am talking to you. My throat produces vibrations, means there are vibrations inside the vocal cord of the speaking system, and because of that vibration sound is produced, and that sound travels to your ears and you can hear that particular sound. So we will learn more about the sound. Now here sound is a form of energy, we can say. Sound is a form of energy which produces sensation of hearing in our ears. Now we will discuss this by taking some examples. Now here look at first figure. Now I have two spoons, or you can take any two things made up of metals and just strike on each other. So what you will listen? They will produce a sound. In the second case you can see here I have stretched string on two supports. Now what I will do, I will just flick the string. Now string will start vibrating and there will be sound of vibration. In the third example here, that I am not drawing that, but that you can perform at your home. Take the cap of the plane and just take it in front of your mouth and blow air inside. You will hear one sound. So these all are the forms of sound, means different sounds are produced due to different methods. Now in the first case the sound is produced due to striking. We are striking two metals. Here I am striking two spoons. In the second case it is due to stretching. In the third case it is due to blowing air. So sound can be produced with different methods. Now let us see how sound is transferred from a point where it is created to farther away. Now for that purpose here I have taken one example. Suppose this is a pond or lake. Now here there is water inside the pond and lake. Now you will stand here and just throw a stone inside the lake. Suppose this is the stone, that pink color is stone. Then now means because of that stone, firstly my water layer, my water surface was stationary. Now because of throwing the stone, disturbance is created inside the water and waves are formed on the surface of the water, and waves are transferred in all the direction of the lake. Now what happens to the objects which are on the lake? For example, any kind of garbage or leaves of the trees or papers and all, what happened to them? They start vibrating at their own places. They don't move from that place. Waves passed away, but because of the speed of the wave, they also start vibrating at their own places about their mean position. So this shows us that in similar way we can say for sound. Now suppose I am talking to you, so I am the source of sound. Now sound energy is created. Now this sound is transferred to you because of vibrations of air particle. Here air is the medium for the transportation of the sound. Now what happens? Suppose there are many particles in line. So when I speak, first particles start vibrating because of my sound energy. So first particle gets sound energy, start vibrating. Now because of its vibration, it disturbs next particle of air. So it also gain the same energy and it also start vibrating and it transfer that energy to next particle. So this process goes on continuously, and in this way the sound is propagated through a medium. Now you have learned already that you can transfer the sound from any medium such as solid, liquid or gases, but sound cannot be transported through vacuum. For the propagation or for the transmission of sound, medium is necessary. Now here air is the medium. Now previously you learned about just striking your hands on bench, then also flowing the balloon, means blowing the balloon with water and scratching on them. So these were the examples that you have studied in the previous standards. So in the first case, bench is made up of wood, definitely it is solid, but sound can be transferred through it. In the second case, water, liquid was the medium of the transfer of the sound. And third case is our case, that I am talking to you and because of air you can listen that. So these all examples shows us that for the transportation of sound, medium is necessary. Without medium we can't listen a sound. In this particular case, for this particular case, you have learnt the example in the previous standard. If you remember, you had performed an experiment having a round bottom conical flask. In that flask, you had fitted the rubber stopper having two holes. On one hole there was ringing bell and in other hole there was just a rod or tube. You heated that pot having which was half filled with water, and after cooling all the steam were passed away and the remaining steam were condensed. So there was no medium inside the flask. So if you shake that flask, you can't hear the bell, and in the first case before heating you was able to hear the ringing of the bells. So this experiment was proved that sound, for the transfer of sound, medium is necessary. Now after heating, vacuum is created inside that flask, that's why you can't hear the ringing of the bells. Now let us move forward. Here I have one tuning fork that you will see in your school's laboratory. Now before any disturbance, now I am not just rubbing that tuning fork or I am not applying any kind of force on the tuning fork. So before that, suppose these are the air particle which are near the tuning fork. Now after when the tuning fork, when I am applying the tuning fork, means I am striking the tuning fork on hand or rubber pad. After that it will start vibrating. So because of vibration, these kinds of disturbances are produced in air particles. Now here you can see these air particles come closer and the next are as it is. Now in the next case, means after some times, these particles will transmit their energy and this part will come here. Means actually the position of the air particles is not changed, but it will transfer the energy. So because of that energy, the next particles will come closer and will start vibrating. So this shows us that you can perform this with long spring also. Just press some part of spring and leave it. So you will see that after leaving that part, next part come closer and the beyond part is far away. So similar experiment you can perform. If you remember, there is one musical instrument having same kind of structure. It is pressed and stretched, because of that sound is created. So these are the examples. Means by this you can see the sound is transferred in the form of wave. Yes, sound is a form of wave. So we will see which form of wave is sound. before explaining the type of wave of the sound, I would like to mention some things here. Here, the vibration is a rapid to and fro motion of an object. Before, means in this example of pond, I have mentioned the word vibration. Now, what is mean by vibration? Vibration is to and fro motion of an object. Sometimes vibrations may be strong enough to be seen by eyes. For example, in the second example, we struck the string, so it was vibrating. That vibrations we can see, but sometimes the vibration can be felt by sense of touch. For example, if mobile is in your hand, when the phone comes from, means if you have any incoming call, then phone start vibrating, so we can feel that vibration. Now I will explain you in detail what is mean by vibration. Now suppose here this is some kind of floor or ceiling, you can say. To ceiling you are hanging one string and you are trying one rubber ball here. Now what you will do, this is the stationary position of rubber ball. Let it stationary. So this is stationary position. Now you will stretch this. You will stretch towards by some distance. Then you will leave it. So what will happen? It will start rotating. It will come here, then come here, then come here, then come here. That means this type of motion is the vibration of the bob. We can call this ball as bob. Now this is the experiment of pendulum, we can say. The whole system is here known as pendulum. Now you can see this is the original position. This is your original position. Let's call it as point O. Now you are giving some displacement to it. So suppose it is coming at point A. Then you will leave it. So it will come back to O. Then it will go towards B. Again it will come back to O. That means it is performing to and fro motion about its mean position. The original position is known as mean position. So this type of motion is nothing but performing the vibration. Means this one complete cycle will be counted as one vibration. So this is what the vibrations are. Now here I have mentioned about the wave. I will explain you what is wave. Now you will see that in the next part, at the point of disturbance, waves are produced. Here the example is, because of stone, disturbance were created on the surface of the lake. So, but the particles of the medium do not change their position. For that purpose, I had given you example of the garbage or leaves which are on the surface of the lake. They start vibrating, but they don't change their position. They vibrate about their mean position when disturbance reaches at that point. Thus, wave is a disturbance that moves through a medium when particles of the medium set neighboring particles into motion. That is, wave motion is a mode of transmission of energy through a medium. So for that particular purpose, I had given you example of my own sound as well. Now, sound also gets propagated in the form of wave. Sound is nothing but wave only. So here, the sound traveling through particular medium. So we will see which type of wave sound is. Now before telling you the type of sound wave, let me explain you. There are two types of waves: longitudinal waves and transverse wave. So here, firstly I will explain you what is mean by transverse wave. Now in this example, second example, you had a string, you are stretching that string and the particles of the string start vibrating perpendicularly. But now suppose you were stretching the string at the central point. Suppose this was the central point, but vibrations are carried to the end. That means vibrations are transmitted from middle to the two ends of the string. So here we can say the direction of the wave was along x-axis, but the particles of the string are performing vibrations along y-axis. That means direction of propagation of wave is perpendicular to the direction of propagation or direction of vibrations of the particle. So in this case, this type of wave is known as transverse wave. This kind of wave is produced on stretched string, and there are many more examples. You can say light wave. Light wave is also a transverse wave. Electromagnetic waves are also transverse waves. Now here I will draw a transverse wave for you. Now pay attention here. Suppose this is the rigid support, any rigid support. Now this is your wave which is progressing along x-axis. Now in this case, for transverse wave, particle will vibrate like this. So this is the example of transverse waves. Means if I have to show you, the wave will go like this. Means you can see here particles are vibrating along y-axis and wave is traveling along x-axis. So this is the example of transverse wave. Now let me explain you what is mean by longitudinal wave. In the longitudinal wave, the particles of the medium vibrate along the direction of propagation of the wave itself. Means direction of propagation of wave is similar to direction of vibration of particles of the medium. Now here in this case, here is the example of longitudinal wave. Now because of stone there was disturbance, so the propagation of wave is along all the sides of the pond. The particle also perform vibrations along the same side. Means like this. Means if I have to show, the wave will be like this. Means the direction of propagation is also x-axis and direction of vibration of particles is also x-axis. So here I will show you how you will draw the transverse wave. Actually, these are the transverse waves which are produced by tuning fork. So here, suppose this is the direction of the propagation of the wave, then your particle will also move along the same side. So because of that, there are some parts which for those particular parts the particles are closer to each other. These points are known as compressions, and there are some parts for which particles are farther to each other. These points are known as rarefactions. Now here in this figure, this particular part is point of compression. and this part is rarefaction. So this is for longitudinal wave. In the transfer wave there are crest and troughs. That we will discuss in the next chapter. So these are the points of compression and rarefactions. Now for the transverse wave there are troughs and crests that you will study later on. Now here the points where we have compressions, the density and pressure of the particles is higher, and the points where rarefaction occurs, the density and pressure of the particles of the medium is lower. Now we will move towards the characteristics of sound waves. There are special characters or specialities of sound waves. We will see that. When sound waves travel through a medium, there is change in density and pressure of the medium. Definitely when sound wave travels, the particles little bit change their position because of vibration. So definitely there will be density change, and now they are colliding each other while they are transferring the energy. So definitely because of collision there will be pressure. So there is change in pressure and density of the medium. Compressions are the region where particles are crowded together. At the compressions, density as well as pressure is high, as I explained. Rarefactions are the regions of low pressure where particles are spread apart. At the rarefaction, density as well as pressure is low. The distance between, now listen this carefully, the distance between two consecutive compression or two consecutive rarefaction is called wavelength. I will explain you. Now here in this particular diagram I have only one compression. So if I go beyond, there will be another compression. Here there is rarefaction. Beyond there will be one rarefaction. So suppose I modify this figure. Suppose this is the point of first compression. This is the point of second compression. Now suppose I will measure the distance between 2 points. Means now I am measuring the distance between two compression. So this distance is known as wavelength. Means it is length of a wave. It is measure of length of a wave known as wavelength, and this is denoted by symbol. This symbol is known as lambda. This is Greek symbol, so this is lambda, and here since it is length, it is measured in terms of meter and represented by lambda. Now change in density from maximum to minimum value and again to maximum value makes one oscillation that I have already explained you. This was the middle position. Now particle going to point A, back to O, again going to B, back to O. So this particular path is known as one single oscillation. Vibration is nothing but oscillation here. So this particular rotations are called oscillations. The number of oscillations per unit time is the frequency of the wave. This I will explain you what is meant by frequency. Now in general we ask what is the frequency of this bus, what is the frequency of this train. That means we are asking actually means about what time buses or trains are repeated. That means suppose after 10 minutes each bus is coming. That means the frequency of the bus is 10 minutes. So here same way the number of vibrations or number of oscillation taking in single second are known as is known as the frequency of the oscillation. Means suppose for 1 second this particular bob is making 10 oscillations. So 1 upon 10 will be the frequency of the oscillation, frequency of the bob. So SI unit of frequency is hertz. Actually, suppose if I'm talking about frequency, the frequency is denoted by this symbol. This symbol is known as nu, Nu. It is Greek symbol, and the formula for frequency is 1 upon T. Number of vibrations per unit time. Here time T is actually time period. Time period means the time for which one oscillation is completed. Now here we will discuss it. So wavelength is distance between two consecutive compressions or rarefactions. Consecutive means you have to take compression, first compression and that compression which is next to it. You can't miss any compression or rarefaction while taking distance between them. Now period is denoted by time, means capital T. Now it is time required to perform one oscillation. Means suppose I have bob, it is going here, coming back, going here, coming back. So total time for one particular oscillation is known as period of the oscillation. Here frequency, which is denoted by nu, so it is number of oscillation performed per unit time. Means it will be number of oscillations performed in 1 second, or here we are taking unit time, so we can take 1 hour also if we want. Then the formula will be nu is equal to 1 upon T. Now here, now I will give you some example to learn about, means we have to learn more concept about sound. Now you can easily distinguish between the voice of your one friend from other. You can distinguish a male voice and a female voice. Now these different sounds are recognized because of different frequencies produced by them, and this is characterized as pitch. Now pitch is the frequency of vibration of a sound source. So here I will write it. Pitch is nothing but frequency of sound source. If the highest is the frequency, higher will be the sound. Now when we will say frequency is higher, now if I am saying more number of words in 1 second, that means frequency is higher. If I'm speaking with very lower speed, means I'm speaking very slowly, for means I'm speaking less words for a second, that means pitch is lower. So we will say pitch is higher if frequency is higher, pitch is lower when frequency is lower. Now here there is another concept which is loudness. This we will discuss